morning, everyone. Today, I'm excited to present Campusaurus, a specialized social ecosystem designed specifically for our campus community. The name Campusaurus isn't just for show, it reflects our vision of an archipelago of islands where each college department from CCS to us to have its own habitat. But there is also a general group where everyone regarding their department can chat and share experiences. We wanted to move away from the cluttered experience of mainstream social media and create a Jurassic themed digital based camp where students can log discoveries, establish community, nest, and engage in daily challenges like our integrated Wordle game. As a computer science study student, we noticed that the campus communication is often fragmented across different group chats and platforms. Campusaurus solves this by providing a unified department-centric structure. The core mission of this project was to build a full-stack application that balances thematic creativity with a robust functionality. Whether you're a CAS or a CCS student, the platform provides a dedicated space to share field notes, which are our department-specific posts, and join nest, which act as subcommunities for projects or interests. Technically, Campusaurus is built on a modern modular architecture. On the back end, we use Flask for our server logic, utilizing a store pattern to keep our data handling clean and separate from our roles. On the database, we implemented a relational MySQL database managed by SQL Alchemy, which handles complex relationships between users, their department island, and their nest. On the front end, we developed a responsive custom UI using CSS variables to maintain a consistent deep jungle aesthetic across all pages. And on the real-time features, we integrated live chat system and a daily wordle to keep the community active and engaged. With the base camp set, let's dive into the actual excavation. To show you how this actually works, in a real-world scenario, Kurt is going to take over for a live look at the system to show you how a student establishes their identity in the archipelago and starts contributing to their island.
Let's start our tour at base camp. As you can see, the UI uses a deep jungle color palette. The latest finds feed is dynamic. It's not just static text. When I log a field node, the front end sends a post request to our Flask backend, which immediately updates the MySQL database. I'm starting my journey by picking my identity. I'll choose the raptor as my avatar and join the CCS island. This sets my home base. Now I'm heading to my specific island. Here we have nests. These are clubhouses for study groups or projects. I can look through existing nests or create one for my own group. I'm logging in a field node. I'll give it a title and some content. Now my whole group in this nest can see my update. It's organized and stays where it belongs, unless I delete it. And for the moments between classes, we have the daily workout to keep the community sharp. The island is fully functional, but Ja is going to explain the brain that keeps this entire ecosystem running.
Behind all of that is a relational database. In this video, we'll walk through how the database was designed and implemented using MySQL and SQL Alchemy. We start with Schema SQL, the blueprint for our entire database. It defines 7 tables. The users table is the core of the system. Every user has a UUID as their primary key, a unique username and email, a hash password, and the profile fields like department, year level, and bio. Notice we use varchar 36 for IDs and generate them with MySQL's UUID function. This gives us globally unique identifiers that are safe to share across tables. Next is the admins table. It's intentionally minimal. It only stores an email address as the primary key. If a user's email matches a row here, they get admin privileges. The post table stores every student discovery, with a category ID that links to either a general channel or a specific nest community. Posts track likes and the comments counter directly on a row for fast retrieval. Comments are stored separately in their own table, with a foreign key back to the post and the cascade delete. So when a post is removed, its comments go with it automatically. Here's how the tables relate to each other. A user is the center. One user can author many posts, announcements, comments, nest, and chat messages. A post belongs to one category, either a general island tag or a nest ID. A nest in turn belongs to one island, which is stored as string identifier like CCS or CEA. The comments table sits between users and posts. It holds a foreign key to both, creating a many-to-many like join. Many users can comment on many posts. The admins table isn't linked by a foreign key. It's a privileged registry checked at runtime by matching the login user's email. This keeps the access control logic simple and auditable. In the application, we don't write raw SQL. we use SQL Alchemy, a Python ORM that maps each database table to a Python class. Here's the user model. Each column becomes a class attribute typed explicitly. db.string, db.integer, db.text. The primary key uses Python's UUID module to generate IDs consistently in the code. SQL Alchemy relationships let us navigate between tables naturally. From a user object, we can access user.post or user comments directly. SQL Alchemy handles the join query behind the scenes. The backref parameter creates a reverse relationship too. So from any post author gives us the full user object, no extra query needed. The comment model shows our foreign key constraints in the code. db.foreignkey post.id mirrors the SQL constraints in schema.sql. Any attempt to insert a comment for a non-existent post will fail at the database level. The connection is configured in database spy. We read our credentials, host, port, user, password, and database name from environment variables using python.env. Nothing is hard-coded. The connection string uses the MySQL plus PyMySQL driver and it specifies UTF-8 MB4 charset to properly support emoji and Unicode characters in post and chat messages. On a startup, TestDB connection runs a simple select one query. If it fails, the app logs a clear error and races rather than silently continuing with a broken database.
In conclusion, Campusaurus is more than just a project. It's a blueprint for a more connected, teamed, and organized campus life. It demonstrates the power of a clean Flask backend paired with a creative user-centric frontend. Thank you for your time.